Alright, hello and welcome to the next lecture. This one is all about variables, assignments, math, and strings. Oh my. So yeah, let's go ahead and get started. What I do want to remind you of is use that assignments tab to see which chapters are part of your zyBooks assignment, because only some are, not all of them. And I split up assignments as well. I split up chapters in between assignments, like chapter 2 first part, for example. This is all in the assignments tab on your zyBooks page. So just click the assignment to see which chapters are part of that particular assignment that's going to be due a certain day on Canvas, right? So make sure to keep track of all of that, because that's your first assignment right there. Chapter 1, Chapter 2, first part, that's your reading assignment, and then there's your Zylab, and there's only specific sections for each of those, right? Chapter 1 Zylab, it has these ones. Yeah? That's the idea. So keep all that in mind, and let us push forward. So let's start with talking about errors, things that can go wrong in C++. Because I was very careful last time to type code that like always worked, but in reality that never happens, right? Once you get to fancier programs. So yeah, the first thing I would like to do is make a folder for today's lecture. So let me show you how to do that. You say make dir and then folder name. So here I am in my CSCI 40 folder for code from class. I want to make a new folder called lec02. Yay, and so now it exists. I can go inside of it and start working there. There's nothing there right now. Let me get there too in my other terminal. So I have one, oops, not lab2, lec02. One for editing, one for compiling. So I have two terminals open right now. All right, so here's the idea. There are a lot of different ways to have errors, and probably the first one that you're going to come across is a compile time error. That is probably the most common. It's when you speak C++ incorrectly. Like the compiler's like, I have no clue what you're talking about, dude. It won't even try to compile and translate your program into something that runs because you just typed something that was so wrong that it didn't know what to do. Okay, so that's something like, instead of int x equals 42, that's saying like impt x equals 42. The second you do this, C++ gets confused. It's like, what are you talking about? And so it won't even try to compile your program. Okay? So that's a compile time error. You'll see that a lot. Then there's runtime errors. Okay? This is the next most common kind of error. Or maybe logic error, I would say, is in between. So a runtime error, it's still a common error. It's when something goes wrong while your program was running and you can't fix it. Something went so wrong that like C++ has to stop the program at that point because things went horribly wrong. Things went badly. And that can't be recovered from. It had to stop the program. So, for example, when you divide by 0 in C++ with ints, it's going to stop the program. So let me show you both of these actually. Let's make a compile time error .cpp file. And so here's me impt x equals 42. And so let me try and compile it. -o compile time error. And so it won't even try and make a new file. It's going to be like, oh, sorry, impt was not declared. Did you mean int? It was very helpful in this case. Yeah, that's what we meant. So if you change it, it'll compile, but it's not even going to try and make the compiled file because it doesn't know what to do. Okay, so that's a compile time error. And then let's do a runtime error. Let's do divide by 0. I'll make a new file. Just call it runtime error. .cpp, and the compiler is smart enough. If I just try and see out, I don't know, 42 divided by 0, it's smart enough to know this will never work, and so it just replaces this line with something that doesn't crash the program. But what I can do to get around that is, let's ask the user for a number. Int x, cout, enter a number, cin x, and so now x could be something benign like 2, or it could be 0. So let's do runtime error. Oops. -o runtime error. So enter number 42. We want to divide 42 by something, let's say 2. So that one worked, made 21. But if I type 0, it's going to be like, bam, floating point exception core dumped. And so that just sounds like we set fire to our computer, which is essentially what happened. It got so confused that was a runtime error, okay? Because obviously we weren't typing this. So there's no cout statement that looks anything like this, right? So that's a runtime error. And then a logic error. I don't think I need to write a program that does this. I think you can understand it from my example. This is also known as a bug, which I'm sure you've heard of before. It's just a fancier term for it. So a logic error, very, very common. But it doesn't crash the program, and it also still compiles. That's why it's so subtle, right? A logic error is when your result just isn't right. Like the thing that you're asking for wasn't what it should have been. But the program, for all intents and purposes, otherwise it just runs, it works, it just doesn't do the right thing. Okay, that's what a bug is. That's what a logic error is. So here's my simple example of a logic error. Like, let's put 42 into x, and then let's make a variable called x plus 1 that stores the value of x plus 2, right? It was supposed to be plus 1, but we'll make it plus 2. The program's going to work just fine, right, for its entirety until it ends, but the value here is not what it should have been. Does that make sense? That's what a bug means. Okay, so hopefully that makes sense. You're going to see a lot of errors. Get used to them. Half the battle of writing a program is solving all the errors that the compiler throws at you or that you encounter. Okay? That's just a fact of life for programming. And while we're here, let me show you like the flip side of this, like really cool stuff that you can eventually write. So here is a demo that I'm about to give you of stuff that we're going to learn in the first half of this class. Okay? I don't expect you to know any of this that I'm about to talk about. Don't worry. It's going to become a lot more apparent and clear as we learn all these concepts, but I want to show you where we're going, okay? I had a really cool Latin professor at Fresno State, Dr. Chapman. Definitely take her class if you can, and you go there. What she did one day is she just started reading from our textbook in fluent Latin, and we were definitely not ready for that yet, but we got to hear like what it sounded like, how it would have been spoken back in the day. And that is helpful all in itself. And so that's what I want to do for you right now. I would like to speak C++ for you so that you can see how it's meant to be spoken. All right? So just sit back and watch. You don't have to remember any of this. You're going to learn it later. But we're going to make the coolest example I can think of, a counting machine. So it's got like a little button, and it keeps track of a count. All right? So let me use all the proper terms that you have not been introduced to yet. Don't worry. But it's all going to hopefully help one day. You can come back here and be like, oh, I learned all this stuff. Okay? So let's make the program. It's going to represent a counter. So I'll make a new file called counter.cpp. Fill it in with the boilerplate stuff that we normally have. And here's what I would like to have. I would like to make my own type called counter. Yeah. Like, let's make a counter called C. Oops, I just messed with my tablet. That's why my computer's unhappy. So let's make a counter called C. We're going to make this type ourselves. Let's initialize it with a dot. So let's start the count at 0. That's one thing we can do. And let's press the button on the counter. Let's be like c.inc. That will represent pressing the button. So that will be increment the counter. And let's do that like 3 times so that now the number is 3. Yeah? Let's do that, and then let's print out the count that we built up, c.getCount. Let's have it be that. And so this will print out our count, which should be 3, and then that's our program. So let me show you how to make this stuff. So this is what we would like to write. Let's make it so that we can write it. So to make our own type, we use the keyword class. So let's make a class called counter. That's what I get for talking and programming at the same time. And all of these things that I'm about to implement inside of the counter class can be public, visible to everyone. The first thing that we need inside of every counter is a count that it's holding on to. So let's make an integer called count that is attached to every counter object, we say. And then let's make an init function, or it's really called a method, that will set the count to 0 of a certain counter. So void init. And it'll just set count to 0. We say void because it doesn't return anything. We say int main because it returns an integer 0. We'll get into that later. So that can be the init method, set count to 0, and then inc as well. It doesn't return anything, it just does something. So we'll say void inc. And what that needs to do is increment the counter. So count, let's change it to count plus 1. Okay? So it was 1 more than it used to be. And then get count, that finally needs to return an int. Because we need to print out the integer. We need to give it back. So it's int get count. And that will return the count that our counter was holding on to up here. All right, so we run this at the beginning, set it to 0. We run this a few times to increment the counter, and then we can, whenever we want, get the count back out and increment it some more if we want to too. So that's all the stuff that you can do with this counter idea that we're representing. Okay, and so now all this stuff exists. We can run it. We can compile and run it. Bam. And we get 3. It's a very contrived way of printing 3, but it was a very cool way of printing 3, I think. Okay, so we just represented one of these little guys in code. Wasn't that cool? So yeah, don't worry too much about this code, but it's where we're going. You'll understand all of it soon. All right, so we just we made our own type called counter. And it had stuff inside of it. Like it had some data associated with it. It had a count that it was holding on to that was an integer. And then it had operations that we could perform on every counter object. So we had like init, we had inc, we had get count. And you can add more. Like you can add like a dec if you want to decrement it, things like that. But we won't go there. Okay. That is my fancy demo for us. Hopefully that's exciting where we're going with all this. It's cool code. But yeah, let's learn a bit more about variables now. Okay, let's go back to where we were at last time. So a variable, right? It's just a name for something else. It's something with a name that can hold a value, let's say. Okay? So when we make a variable, we make space for ourselves to store something. Int x equals 42, I want you to think of that as making a box in memory that holds the number 42. Okay? That's the idea. And variables, their names, there's some special rules when it comes to naming variables. Variable names, they have to start with either an underscore or an alphabetic character. Doesn't matter the case. But after you have the first character, then you can start using numbers if you want to. Okay? Then you can use everything, including numbers. So it's incorrect to say, like, here's a variable name x space y. It doesn't work. That's not a valid variable name. Okay? So valid ones are like underscore underscore hello. That's totally fine. Capital A, B, C, or capital C, O, 0, O, 7, whatever you want. Doesn't matter. As long as you follow these rules, those are the names that you can use. And because you can't write spaces, people have come up with 2 competing schools of thought as to how to write a bunch of words as a variable. One is called camel case, because every time you have a new word, they make it capital, so it looks like the humps on a camel's back. So look at all those. That's one way of writing a variable name with a bunch of words in it. And then other people like to use underscores instead. Okay, so you'll see that a lot in code, but now you know. So that's variables. What's really happening is memory is getting set aside for whatever you're calling your variable, okay? You have to say that it exists, right? So to make a variable in C++, you have to say what type it is. You got to say what kind of stuff you can put in it, right? So you can say int x, for example, to make a variable called x, but don't give it a value just yet. That's called a declaration. Just say that it exists. Make room for it, please, right? And the question is, if I say this, if I say int x semicolon, and I try to print x out, I declared it, but I didn't give it a real value yet. What in the world does x hold right now? Like, what would happen if I printed x? All right? And the answer is complete garbage. It holds random memory values, just whatever was there. Okay? It doesn't make it 0 or anything nice. It's just garbage. Complete garbage that you should always avoid. Okay? So let me show you that. uninitialized vars.cpp. Let's make a program called that. So let's make a few variables: int x, int y, int z, I don't know, p. Let's make a double for fun. Double d. Let's try to print all these out now. I haven't given values for any of these, so they are just forced to be garbage memory values. They are uninitialized. They're declared, they exist, but they're uninitialized. So I'll compile and run. And so look at what we get. These are the random numbers that are in memory right now for all these things. If I rerun it, I get different values. Isn't that nice? And just due to quirks of my computer, the double is always 0, but you can't bank on that. So see how I rerun it and it's random stuff still. So it's just garbage memory that you should avoid. Okay, so never declare and not initialize. Okay, so always initialize your variables, and there are a couple ways to do it. So if you do it like this, here's the first way. You can say int x, declare that it exists, and then sometime later, like it starts out question mark, sometime later before you really print it or need its value, you give it a number, right? You just say x equals 42. You don't have to say int anymore because it already exists. Just say x equals 42. And that'll make it 42. That will work. The other way to do it is to declare and initialize at the same time. That's what I've shown you already. Int x equals 42. Okay, so that'll just work. It just makes x and makes it 42 at the same time. Declares and initializes all at once. Technically, there's a third way if you count cin. You can declare. Obviously, there's still nothing in it, but the second you say cin, get something from the user and put it into x, that initializes it. Yeah. So just make sure, before you ever use a variable, before you need it, make sure it's initialized. Okay? Otherwise, as I have shown, weird things can happen. Okay? So remember that. And I've been showing you like the way to give values to variables is with this equals sign. And I'm very sorry about that. Equals, in my opinion, equals was a very bad decision. All right, maybe the arrow would have made more sense. I think that would have been a lot better, like because you're really putting a variable from the right into the thing, or you're putting a value on the right into a variable on the left. Right, information is flowing to the left. So think of it as an arrow if you'd like. So just a line with some equals on it is called an assignment statement. Okay. An extra special reason why we don't like equality is because we might think of it as equals in math, and that is not the case in C++. This equal sign has nothing to do with the math version of equality, okay? In math, when you say equals, it's like something has a value and it never changes. In C++, you can change the value of a variable. That's totally fine. And so that's why it's extra sad that it's an equal sign. All right, so let's see, what did I want to talk about here? Let's yeah, let me show you just what you can do here. So the idea when you're initializing a variable, when you're giving it a value, you use this assignment statement, you put something over here on the right, and it becomes the variable's value, right? So let's just do that. vars.cpp. Here's int x. I can set it to be 42. That's fine. CI x. That's totally fine. Let's set up for what I'm about to do. So it prints 42. Cool. That's one way to declare and initialize. You can change that variable's value after it's been created. I can be like, oh, okay, I'm actually done with the 42 in x. I'd like it to be 55 instead, please. And so now when I print, it's 55 because I changed it. It doesn't have to remain 42. Variables' values can totally change. That's totally fine. And then here's a very, very confusing line that actually works. You can say x equals x plus 1. And this is why I want you to read it from right to left, because it's the right-hand side is getting computed and then put into the variable on the left. So it's doing math. And this becomes, you guessed it, 56. Because it was 55, and it made it one more. Isn't that fun? Shorthand for this, because you do this a lot in C++, you want to increment a variable. Shorthand for that is just say x++. That does the same thing. That's shorthand for x equals x plus 1. Which is funny, because now you know why it's called C++. It's one more than C, which was the old language. Okay, so now it's 57. Can you follow these lines and understand why x prints 57 now? That's important. Okay? So that's my spiel there. Yeah, let's get a bit fancier with the kinds of things that you can compute in C++. So you don't just have to say 55, 42. You can have very long expressions, we say, that eventually compute an answer. Because C++, we want it to do our bidding, right? So eventually, we need to get, like, things that we put in variables and things that we print, we need to get them down to actual values, we say. Values that we can print, that actually have meaning, right? That are the most basic thing that we can do, that we could print. Right? So a value, or also called a literal, it's a basic element of a type, we say. So for ints, those are like the numbers that you could possibly have in an int. 0, 42, -1. You don't have to do any extra work to get to the final answer. Okay? You don't have to like add things, compute extra work. It's just, you got a number. That is a value as far as an integer is concerned. Okay? If you don't have a value yet, you have what's called an expression. Okay? That is any combination of both literals and operators. Okay? Things like plus, minus, the give to cout operator, all that stuff. Okay? So yeah, a value is technically a special case of an expression. So here is an expression. Dun, dun, dun. 2 plus 3 times x divided by 7 minus 1. It does use the normal order of operations and things, but depending on a value of x, this might become, it might evaluate to the value 42. And that's what would be printed if you tried to see out this big long thing. Okay? That's the idea. That's the difference between an expression and a value. Okay? So it's not like 42 plus 7. It's got to be something that an int could be, the basic things, the basic elements of that type, like 42, -5, all that stuff. That's the idea there. Yeah, that's what I wanted to say. So you can do fancy work, and eventually C++, before it prints it or puts a value into a variable, it sets it. All right, it gets it down to a value before it sets it. All right, and that's what you can use these assignment statements for. It's putting B into A. So you end up with a variable that looks like this, in a sense. Yeah? That's the idea. Okay, so I think that's what I wanted to say to us there. Let me just check my notes and confirm. Yeah, I think so. So let's move on to division, because there's more than meets the eye as far as C++ is concerned. So take a second, let's pause the video, and try and figure out what the following code should print. All right? So pick your best guess, and come back, and we'll see if you were right. Okay, so let's do a new file called division.cpp. So let's do exactly this. Int, can I just copy and paste? Cool. All right, drum roll, please. It prints 2, in fact. What? So the answer is A. I'm sure you're scratching your head quite hard right now, and let me tell you why it printed 2. All right? It has to do with something called integer division, which is a complicated topic that I want to teach you right now so that you never get burned by it. All right? So remember that integers are whole numbers only, zeros, 1s, 2s, and 3s, and all that stuff. 2.5 is not an integer. It is not within the int cloud, right? Division, the operator division, the slash, in C++, operates differently on integers than it does on doubles. Weird, right? Because there's no room in an int for decimal places, there is no 2.5 representable as an integer, ints only hold whole numbers, okay? And so it doesn't round. It's very lazy in that sense. The decimals just get dropped. Even if it's 2.5, 2.75, it's rounding that to 2 because it's just dropping off the decimal places because they can't fit. Okay? That's what's happening. So that's why 5 divided by 2 using integer division just becomes 2. The 0.5 just gets chopped off. Okay? It's always rounded down. Remember that. That's called integer division. And integer division was happening because I had an int x, that was an integer on this side, and I had the int 2, that was an integer on that side. And so it picked the integer division operator, computed just 2. It chopped off the 0.5. That's why it printed like that. Isn't that weird? So let me show you how to get the right answer, the one that you really want, most likely. So we wanted it to do double division. We wanted it to use decimal places, okay? And to get at that, to make sure that our slash does double division, we have to make sure that we manipulate the types that are involved on both sides of the slash, okay? Double division, it depends on the types that are involved in the slash operation, not the type of the variable that you're assigning to. So even if I try to do something like this, double d equals x over 2, this is still doing double division, or still doing integer division. It makes 2.0 because it then converts it to a double. It's still not what we wanted. Okay, so again, it prints 2. Here's the idea. If you want to do double division, one of the sides of the slash better be a double, all right? So if you do int slash int, you're getting back another integer. It's doing integer division. But if you make one of the sides of the slash, either one, a double, like you do double over int, then it makes it a double. Then it does double division. It gives you decimal places. Okay? That's the idea. Just make one of the sides a double, and you're happy. Okay? That's what's going to work. So double, by the way, is known as what's called a floating point type. You might hear that word again. It just means that it has a decimal place in it somewhere. That can float around, we say. Okay? It can be wherever. So yeah, let me show you the easiest way to make the 2.5 using x. You could have done it like this. You could have made the 2, instead of just a 2, it could have been 2.0, and now it's doing double division. Because one side of that slash, the right side, was a double. Now it's given us 2.5. See that? That's what we want. Potentially, maybe you wanted to make x a double. It's not a double. You still want to do divide by 2, the integer. So if you need to make an int variable a double, if you need to convert it, you use something called static cast. It looks very ugly, sorry, but that's just the way things are. You say this, static underscore cast, and then you use angle brackets. Again, I'm sorry. And then you say the type you want to convert to. So I want to make a double. Then you give parentheses. I want to make a double out of x, please. That is the key. That's how you can transform an integer x into a double. You use static cast. Okay? Boop, boop, boop. So, the alternate is static cast into a double of x over the 2. Okay? So this will still do double division because this is an int, but this side I converted x into a double using static cast. Okay? This is the cleaner way to do it, but this is the way you can still do it. Whee! And so I get 2.5 again. Yay. Okay. So now you see why I dedicated a section of the lecture to division. All right. Also, if you want to print doubles, your book gets more into this, but let me show you the idea right now. If you want to print a double, you might want to print a certain number of decimal places. So let me show you how to do that. You can use fixed and set precision. And set precision lives in the C++ header. This stands for IO, input-output manipulation, but I'm just going to say IO manip. All right, so I have to include that. IO stream and IO manip for, this gives us set precision. I think IOStream gives us fixed already. So these are things, these are like pretend variables that you can give to cout. And they don't print anything, but they control how it prints future things. Okay, if that makes any sense at all. An example will make it clear. So here is what I can do. I can say cout fixed. It's just like a variable. Cout set precision, and like, I don't know, 5 or something. And then I can give a double. I can say, I don't know, x divided by 2.0. Something like that. And watch what happens. Whee, I get this. 2.50000. Oh, so here's what's happening. Fixed says always use the decimal point, cout. They're just little variables, but they control how cout prints future things. They don't print anything themselves. Fixed always show the decimal place, and then set precision of n. Always use n decimal places of precision. So it could have just used 2.5, and that was the default. But we said we wanted 5 digits of precision, so you better give us some zeros, cout. Okay? So if you ever want to print a double with a set number of decimal places, fixed and set precision are your friends. All right? So that is numbers, division. Now I want to switch gears, and that'll be the end of today, to text, to characters and strings. Okay? So let me show you what's going on there. Let's talk about characters. Like everything in your computer, at the end of the day, when you're running your programs, it's all getting converted into ones and zeros, right? So all of our numbers are ones and zeros, even the doubles with the decimal places. Characters are ones and zeros. Strings are a bunch of ones and zeros. It's very odd, but let me show you how it's all working. So every char, for example, is really just secretly a special number, okay? Your computer knows, like cout knows when you're printing a character, it knows that it's getting a number, but it needs to like look it up in a table to see what character I should be printing to the terminal. But we can have it forget about that. We can convert a character to an integer that it really is secretly and print it out, okay? So let me show you that. I don't know, I'll make a new file called chars.cpp. Cout static cast. I want to convert into an int of the character a, which was a char. And oh man, is the character a 65? And it does go in order, so like the character for b is 66, but it is weird for other things, like the space character. That is the number 32. It just knows to print a space whenever it has the number 32 stored into a character. It's very weird, but that is the encoding. Everybody, every computer these days uses this kind of encoding, and it's called ASCII, okay? And it's arbitrary, like, we just had to agree on it. So, like, a bunch of people back in the 60s, they got together, and they're like, this is the order of the characters. These are the numbers that we're going to assign these characters to. And then everybody was like, okay, yeah, we're going to do that in all our future computers. And so we ended up with the ASCII encoding, and let me show you the ASCII table. Dun, dun, dun. Can I search your book? That would be useful. No, I guess I'll just have to use Wikipedia. Boop. Boop. Here's the ASCII table. Scrolling. There's some unprintable characters, so these are random weird things. And then you have printable characters, so look at the decimal. So this is 32. The number 32 is the space character. The number 4 is 52. The 0 character is the number. It's encoded as the number 48, which is weird to think about. And then A is 65. It goes in order after that. And then the lowercase characters start at 97. That's lowercase a. And all the punctuations in between. But yeah, that is ASCII. That is how your characters are being encoded inside of the computer. Isn't that cool to think about? All right. So that's that. And of course, you can combine characters into strings. We have the string type for that. And we can modify our strings piecewise. So let's say we want to, like maybe we don't like the capital H, we want to change it to a lowercase h or something if I have a string called hello. Okay? There's a way to do that. Okay, so let me show you all this. So strings are made up of individual characters. You can access each of them. You can modify each of them. This is the syntax. You say, you give your string, whatever the variable that holds it, you say s, and then you say dot at, okay? And so it's like you're acting on the s variable. You say dot, I want to get the at of us. At index I, we say, okay? And so that will give us the ith index of a string s. And that sounds weird, but let me just show it to you. Here's my string. I'm storing hello. This is how it's encoded inside of the computer. It's just a list of characters in order. And they are all accessible, each individual character that makes up the string hello, they're all accessible using these indices. And the numbering starts at 0. This is going to be a pattern in computer science. The numbering always starts at 0. So the first character is at index 0. The second character is at index 1. This is a very common thing to forget, okay? So that's why I'm stressing it right now. And so if I want to get the h out and I want to print it, I can say s dot at, assuming that the string is called s dot at 0. And that will give me back the h. And I can print it, I can change it. Let me show that to you. Dun, dun, dun. So I'll make a new file, strings.cbp. I want to use string variables, so I got to include the string library. That's double quotes that make a string. So if I want to just get the first character, s at 0. And that'll print the h by itself. Yay, so I got an h. I can change. I could change that thing using the same syntax. So s at 0, let's make it lowercase. Let's make it lowercase h character, okay? You can use it like that. Pretend that this is a variable. It'll get out the 0th character and you can change it. You can set it using the assignment statement. So now if I print s, it changed. It wasn't capital hello anymore. It's lowercase hello. Yay. Isn't that nice? So yeah, that is indexing into a string at a certain character. Don't try to access index 5. That doesn't exist. That'll be a runtime error. All right. So here is something for you to try. Okay? Don't worry about this right now because this is asynchronous. But what I'd like you to try is make a string variable called s2, have it store this weird thing, and then I want you to print out ABCD using just this string, okay? ABCD in that order. All right, so try it. And the secret is, of course, the indices. What's the index of A? It goes 0, 1, 2, 3, 4, 5, 6. So the A is at index 1, the B is at index 6, the C is at index 2, and the D is at index 0. All right, so you just do cout s2 at 1 for the A. And it's 1, 6, 2, 0. And then, I guess I don't want the new lines for these intermediate ones, so let's do that. Yay, so I got my ABCD. Cool, huh? So that's how you access individual characters and potentially modify them in a string. Now you know. Something that will become apparent soon that you may run into trouble with is if you try to use cin to read into a string variable, it's only ever going to get a single word, sadly. Let me show you that. Let's say string input, and we'll cin into input. let's have a little prompt and everything too. Cout, enter a string. Dun dun dun. And we'll print it right back out with a new line. Here's the issue. I can be like, hello world, and type extra things, but it only ever gets the first one. When you read using CN, it only ever gets the first thing. If you want to get everything, including the spaces, you use getLine. That's a special function, okay? So it's part of the standard library. It's in the string library, and this is called a function that we can use. We can access the entire line if we run that function like this. We say that we're calling this function, like we're yelling to it. We'll talk more about that later. But yeah, that's what you would do. You'd say, instead of it this way, let me comment this out because that won't work anymore. Instead, what you do is you say, there, I guess. What have I done? There we go. Let's keep the string variable. Instead of saying, using CN, just like this, you say, because this one doesn't work. Only gets one word. Instead of that, you say getLine, CN, and then the string that you want to populate with the line's contents. So this will read an entire line from CN, from where the user starts typing to when they press enter. And that will get all the spaces in between as well. So let's try it all over again. So, hello world, blah, blah, blah. Bunch of spaces, hit enter, but it got them all. Okay, it put it into the input variable, every single thing that we typed. And it printed it right back out. So that will be useful one day. Now you know it. And then finally, for today, let's talk about capitalizing a lowercase string. So that is something I kind of did backwards. I hard-coded this H right here. But there is a trick. Let me show the trick to you. Let's make a file called capitalize. And this will get us thinking. So that it always works. So we want to get a lowercase word from the user. Oh, let's do that. Cout, enter a lowercase word. And we can use CN for that. So string word, CN word, and we need the string library because we're using the string type. So now we have that word, and what we would like to do is, no matter what it was, capitalize it. We have no control over what it was. We just know that it's a word and there's an alphabetic character at index 0. We want to capitalize that character. We want to be able to turn hello into capital hello. We want to turn ABCD into capital ABCD. Interesting, huh? So the way to do that is you're always looking at the character at index 0. That's the H, that's the A. You want to transform it into the capital H, the capital A. How does that work? And that brings us back to the ASCII table. I'll make it normal again. But notice that there's always the same offset between the lowercase character. A is 65, capital A is 97, and B is 1 after, and so is capital B. There's the same offset between the capitals and the lower cases. Yeah? So we were up here with A. We have to bring it down here to capital A. We have to subtract a number. To go from B to capital B, we subtract the same number. Do you see that? Because it's the same offset. It's just shifted. So the way to do that is we just think about where we are on like the number line of characters, because it is a number after all. We need to go from, here are the capital A's, the capital B's, and here are all like, here are those. We have all things in between. Then we have the lowercase a, the lowercase b. We have to just offset by that distance. And it's the same distance for each. Those are the same. Just offset. All right, so let's figure out what that distance is. And remember, these are numbers. What's the distance between lowercase a and capital A? It's just they're numbers. We can just do this in C++. We can say character A minus character capital A. That is correct C++ to do. And that is the offset, is it not? That's how far away the, that's this distance. I call this distance D. This is D, yeah? Crazy, right? So, yeah, that's what we want to do. We want to offset our lowercase character by D. We want to subtract D from it. Okay? So, let's do it. Now we know, and this will work. So, int D is whatever that offset is. The distance between lowercase a and capital A. Sure. Now we have that, and let's lowercase that character now. So we're going to go in, we're going to say word dot at 0, that's the first character, and let's set it to be, well, whatever character it was, offset by D. You see that? Crazy. But that'll bring it back down. It'll bring the A down to capital A. It'll bring the B down to capital B, because that's the order of the characters. And it'll work for any character that starts with an alphabetic lowercase letter. And now if we print out the new word, this is the distance between lowercase a and capital A. Whee! Yay, lowercase word, hello. Makes capital hello. Makes capital ASDF. And it works for any possible character. Isn't that cute? So that's how we can use C++ to solve interesting problems, right? I think that's a very interesting problem to solve. It's not too simple, right? We had to think for that one. So that's where I want to stop right now. That'll be the end of this week's lectures. Next time, we're going to talk about binary. We're going to learn binary and talk about the sizes of things like bits and bytes and stuff like that. It'll be really cool, but you have to wait for that one. So I'll have that for you next week. But now is when I'm going to record the lab intro video. Okay, so go click on the lab now, because after every lecture there is lab time, right? So I'm going to introduce the lab 0, and that is something that you should start working on. Okay, so I'm going to record a video to introduce it, and then you should be able to go off, get started, and turn it in. Okay, so I'll see you in the lab video.